everyone, welcome to this section of the course. We are almost at the end of the trigonometric chapter. So in this section, we'll be covering some trigonometric identities and proving them. So let's look at the first example here. We have a rather complicated expression made up of three terms here. We have two lots of sine theta over 2 and times by cos theta over 2. Now I'm cordoning off this very first two terms here because it seems like we can apply the uh, double angle for sine here. If we take our a to be alpha theta over 2, so then double A will be simply just the theta on the right hand side. So looking at this expression, we just gonna replace our divide. If we just take any of those angles and divide them by 2, so dividing each and every angle here from the formula by 2, what we end up with is just simply sine theta. So the very first two terms here with this scale factor of 2 can be replaced with sine theta. So we will simply have sine theta times cos theta. But there's nothing like half of sine 2 theta yet. What do we do then? Well, with the same formula again, if we take this double angle formula for sine and we take that formula and divide it by 2, basically putting a factor of a half in front of both sides, like so. So if we divide both sides by 2, we'll end up with what we have in our working out so far. So sine theta times cos theta is simply equals to half of sine 2 theta here. So this is actually one of those identities that's very helpful when you see questions that involve integrating sine theta multiplied by cos theta. Okay, so we will see questions like this when we discuss integration and differentiation. So you can replace that integral with half of sine 2 theta, and that would be a better way of solving that problem. Okay, so let's look at the next example. Here in example 2, we have to show that 1 plus 4 theta equals to 2 cos the square of 2 theta. Right, so what do we do when we have 4 theta? We can think of it as that's 2 times 2 theta. Okay, so we can throw at it either one of these formulas. So which one do you think is the best? Either of these three theta: equation 1, equation identity 1, identity 2, or identity 3. Well, we look at the right hand side. If we start with the left hand side, the right hand side will only have cos in it. So we want our right hand side to have only cos in it. So we take identity 3 there. So if we take rewrite 4 theta, well, we can take this identity and double the angle. So if I double the angle to 2a will become 4a, but I'm gonna write 4 theta, and that means that I don't have to change the coefficient. I am changing the coefficient of the input rather than the coefficient of cos. So the 2 and cos square remain as they are. Instead of a single a, I will have a double theta, and the minus 1 remains as it is. So that's the expression for cos 4 theta. And if we add 1 to this expression, so 1 plus cos 4 theta will simply be 2 cos square of 2 theta minus 1 plus 1. So because we added this 1 to both sides, so this plus 1 and minus 1 cancel away, and that looks now like our right hand side. We started with the left hand side here. We said we're gonna multiply the angle by 2, so then we end up with this expression here. When we substitute that here and add the 1 and the minus 1 will simply cancel away. Okay, so we had what we had, the expression was given to us on the right hand side. Okay, so let's look at the next example. So with this case is to prove that tan of 2 theta equals to this fraction. If we start with tan of 2 theta, look at on top of the page here. This identity here is for our double angle formula. Tan of 2 theta can be written as tan square of theta on top of 1 minus 2 tan theta, or rather 2 tan theta 1 minus tan square theta. So we can take that, and what do? We look, what's the similarity between this fraction and this fraction here? Well, the 2 is the same on top of the both fraction, but the tan is missing on the top. So how did they make the tan disappear? Well, of course, we can divide every term by tan theta itself. So if we do that, we end up with this expression here. Tan theta and tan theta on the top cancel, but we make sure every term singularly is divided by tan theta. So then, of course, 1 over tan in the denominator is cotan, and tan squared divided by tan is single tan. So we end up with what we were asked to prove. Simply right hand side equals to left hand side. So moving on from there, this final example here has root 3 cos 4 theta plus sine 4 theta equals to 2 cos 4 theta minus pi over 6. So we can look at perhaps this expression here where, because on the right hand side I see there is cos, and inside the bracket there is alpha minus beta, and we can call our alpha to be 4 theta. We can call our beta to be pi over 6, and use those two and substitute that into the right side of the expression here. So I could call 2, actually there's a factor 2 in front of that, so 2 lots of cos of 4 theta minus pi over 6 means that I have to multiply the right side by 2 as well, because this expression didn't have a 2 here. Obviously there was 1 there. So now I multiply every term here by 2. So I'm just going to put the plus 2 here as well, because I know I have 2 terms. So cos alpha is going to be cos 4 theta there, and cos beta is going to be cos of pi over 6, which I'm guessing is okay, I'll deal with that in a minute. So sine of alpha means sine of 4 theta, and sine of beta means sine of pi over 6. Now sine of pi over 6 is a half. Okay, so I can evaluate sine of pi over 6, and sine of pi over 6, cos of pi over 6 is going to be root 3 over 2. Yes. So we will have the right hand side equal to 2. I'm going to leave cos 4 theta alone as it is and evaluate cos of pi over 6 to be root 3 over 2. So this 2 and that 2 cancel away, and at the same time this 2 will cancel away with the half at the end of that term there on the top. So simply put, we will have root 3 times by cos. I'm looking at the final answer on the left hand side, and I can already spot that this is exactly the same as what the question asked us to prove. So uh, rather we started with the left hand side. No, we started with the right hand side here, and we ended up with the left hand side of the expression here. So that proves point here. I believe this is the final example. Let me check.